to go to, for some reason, I was able to share my entire desktop today. I don't even know what I did and did not do. Usually I have to share one file at a time. But anyways, you should be able to see our course schedule. And I do want to remind you, a lot of people thought we're going to have quiz for last week. So our schedule, our course schedule was adjusted to reflect the Labor Day off. So everything was pushed one more week. So there is a latest updated version of our class schedule. So don't forget to download that from Blackboard so you have the latest one. Okay, we're moving down to Module 3, hypothesis testing. As you can see, we're going to spend the next 3 weeks really slow down and dive deep into hypothesis testing. The reason is that from my all the years of experience, hypothesis testing is one of the most complicated ideas. It relies on a lot of concepts we introduced previously: probability, sampling distribution, normal distribution, calculation of standard deviation. A lot of that all piling together. And there is a process that you have to follow, and you have to learn how to draw conclusion. Okay, so we're going to slow down and explain the purpose of hypothesis testing. It is a complicated, statistician doesn't make it easy to perform, but it's actually very useful because all of the inferential statistics we've covered so far helps you to make an informed decision. If all of a sudden you notice that something was changing or something you're doing, for example, you have a new mixture coming in, you're making a cement and a new mixture comes in. Theoretically, they're the same model number, the same capacity, supposed to perform exactly the same. But one of the variable was changed. As a result, if you want to come back and test it, the strength of the material, the strength of the concrete, viscosity of it, whatever that is, hypothesis testing is something you can collect from your process real quick, perform some experiments, collect your data real quick to confirm if your process has shifted or not. It gives you a definitive answer a definitive conclusion to answer your question. All right, so very useful, and I like to slow down and go over this concept. Okay, one more thing. So since we're gonna spread this out in 3 weeks, I'm going to make the homework available this week, but it's not due until we go over all of it, until the 7th, because I really have to go to the 2 different cases. All right, so I will make it available today, but it's due almost 3 weeks later. Okay. All right, so let's move on to Chapter 9. We'll introduce hypothesis testing, but in Chapter 9, we're only talking about one population. We'll expand the idea to 2 populations or even more in Chapter 10. So all I want to cover today is Night 1, just to explain what is the hypothesis testing, why are we performing it, and what are the statistics we need to calculate in order to draw a conclusion, and how do we draw a conclusion, how do we set up a test. And next week, since we have a quiz today, I'll probably have a short lecture, and next 2 weeks, we're going to go over the different case, just like confidence interval, to go over the case when population variance is given, and go over the case when population variance is not given. Keep in mind, we can perform all kinds of hypothesis testing on the population parameters, not just mean. We can provide that on population variance, population standard deviation. If you have a discrete random variable, we can test on the proportion of that. All right, so there's all kinds of we can perform, but for our lecture, we'll mainly focus on population mean, hypothesis testing on population mean, because the rest of the hypothesis test follow exactly the same procedure. As long as you know how to perform the mean, the variance, the proportion shouldn't be a problem. Okay, so I will spend next week to go over Night 2 and Night 3. On week 3, one of the most complicated concepts this semester, we'll go back to type 1 and type 2 error. Here, type 1 and type 2 error. Where did that go? We'll see that later. Okay, type 1, type 2 error. In other words, all the conclusion we're drawing is by collecting data from our sample and draw a conclusion about the population. But we all know drawing a random sample, there are different samples we can collect. And sometimes we could collect outliers. As a result, our sample average is skewed. So what would happen if you collect a sample that leads to the incorrect conclusion? It is possible because we're using a part of the population to draw a conclusion. The probability is not very high, but it's not zero to make the mistake. So we'll address that part. And how do we control the risks? By choosing different sample sizes. We keep emphasizing on the sample sizes because in reality, as engineers, sample size is the most certain things in our control. The more samples you can collect, the more information, the more reliable the analysis is. But there are different processes, different experiments. Sometimes it's very hard to collect sample. Okay, but the rule of thumb is the more sample you can collect, the more accurate the test will be. So let's go down to here, learning objective. Let me highlight what we will be able to do and what we will not cover. Okay, so hypothesis test help us to make decision. So we'll show you how to perform hypothesis test and make a statistic informed decision. And we'll show you how to perform a hypothesis testing. Very similar to our confidence interval, when sigma is known, population variance is given, we'll use z statistic. When it's not given, we'll use the t-distribution. Number 3, we will not go over the hypothesis test on variance and standard deviation. Or number 4, population proportion. But we will show you how to use p-value to make a decision. We will show you how to calculate power and errors. Okay, because it is important to choose your sample size properly to address the risks of making a mistake. And today, we're going to explain the relationship of confidence interval and hypothesis testing. Since we're going to have quiz 4 today, I hope all of you have a pretty good understanding of confidence interval because we're going to elaborate confidence interval to show you how to perform a hypothesis testing. Okay, don't worry about chi-square or goodness of fit test. Actually, if we have time, I would like to show you how to perform goodness of fit test. This is a hypothesis testing performing on a given probability distribution. In chapter 3 and chapter 4, we've talked about a lot of different probability distribution. If you remember, normal distribution, Poisson distribution, uniform distribution, binomial distribution. All right, but how do you know if your data fits one of those distributions? By now, you should be able to know in your project which variables are continuous, which variables are discrete. But can you fit them into an existing probability distribution? Goodness of fit test will tell you that. If I have time, we're going to go over that. Okay, so I will. I'd like to go over this if we have time. So let's get started. Okay, what is a hypothesis testing? Okay, hypothesis testing started with a null hypothesis. This H0 is our null hypothesis. Okay, this is what we believe, what our current process is. We believe our current process has a population average of 50 centimeters per second. So this is what we believe the current process is. Current condition. Okay. Every time you suspecting something or you're trying to make an improvement and change your current population mean, then this is what we're trying to find out. This is what we're trying to prove. Okay. So if let's say if the new mixture comes in, it doesn't change our process at all, our conclusion will be H naught. We're still meeting the current condition. If the mixture comes in as a new model, it apparently changes the process, changes the property coming out of that process. Then we're going to perform hypothesis testing and conclude alternative hypothesis that my population mean has changed. Okay, so we start with a two statement, null hypothesis and alternative hypothesis. After we perform the analysis, our conclusion is one of the two. We either conclude the null hypothesis that yes, our current condition has not changed, or we conclude alternative hypothesis that yes, our current process is not 50 centimeters per second anymore. We conclude the new process is our alternative hypothesis statement. Mu does not equal to 50 centimeters per second anymore. All right, so we start with a two statement, we conclude one of the two statements. Okay? Now, let's elaborate from here and relate the hypothesis testing to confidence interval. As you can see on the bottom, we can perform two-sided hypothesis testing. We can also do one-sided hypothesis testing. How do we know if it's one-sided or two-sided? Based on the alternative hypothesis. Our H1 will tell us if it's two-sided or one-sided. When we return our null hypothesis as mu not equal to something, that means this is a two-sided. What is two-sided hypothesis test? It is you calculating two-sided confidence interval. And if your alternative hypothesis is written as mu greater than 50 or mu less than 50, these are both one-sided hypothesis testing. In other words, you'll be deriving one-sided confidence interval. Okay, let's elaborate more on here. Let's start with my null hypothesis. Null hypothesis believe my mean equals to 50. This is my current condition, while my alternative hypothesis believe it is not 50 anymore. Okay. So what we believe our current process is a population, with a mean of 50. Okay, this is what we believed. Now we need our data to verify that statement. Okay, before we do so, we'll have to establish a confidence interval. How do we determine the confidence interval? By the choice of alpha. If you remember, our confidence interval is 1 minus alpha percent. Estimate on where the population mean would be. Okay, so based on our choice of alpha, we can generate a confidence interval. What's going on with this today? So within here, I have my lower bound and my upper bound. Within here, this range is my 95% confidence interval. In other words, we have a 95% confidence that my true population mean will locate it between this lower bound and the upper bound. And this area under this bell curve is 95% probability. Okay, which leaves here alpha over 2, 0.025, here 0.025. Okay, now we are going to collect data to validate the statement is true or not. Okay, so let's do this. So I start designing my experiment, and here's my sample space. I have a few data points, in my sample space, after we perform experiments, we've collected a few data points randomly, okay, and calculate that sample average. I'm going to make this a sample average 1, okay? If the sample average 1 is located here, okay? In other words, case number 1, my sample average 1 is located between my lower bound and upper bound. My sample information is consistent with my null hypothesis. This information is consistent. Then our conclusion is that we fail to reject our null hypothesis. In other words, we concluded all right? Because H1 is what we're trying to prove. If my data tells me my sample average is consistent with the confidence interval established in my H0, that means it's consistent. I cannot reject my H0. Okay? Let's give you another case. Let's say in my second case, I'm collecting some other samples. Here is my X2. And my X2 is located here, lower than my lower bound. That's my case number 2. Okay, my X2, my X2 is lower than my lower bound. In other words, my sample average is outside the confidence interval. So it is inconsistent. It is inconsistent with the confidence interval we've established in my H0. As a result, we believe this sample probably comes from another population. I'm going to sketch it here. We don't know what that is, but at least we can sure that population mean is not 50 because the sample we've collected from that green population, the sample mean is outside the confidence interval that we've established in my H0. Okay? As a result, we reject my H0 because my sample information is inconsistent with it. Since we reject it, we conclude H1. What does H1 say? Our population mean is not 50 anymore. Okay, let's give you a third case. Okay, let's see. Here are the samples I've collected. Okay, that's my X3. And that's the location of my X3. Okay, case number 3. My X3. My X3 is even greater than upper limit of my confidence interval. Is it consistent or inconsistent? It is outside the confidence interval, right? It's actually inconsistent. What is inconsistent? The information we collect from our sample is inconsistent with the confidence interval established in my H0. Right? Since it's inconsistent, we reject the null hypothesis. And therefore, we conclude H1. Case 2 and case 3 will lead to the same conclusion. So when we're collecting sample, we don't really know where the sample average is going to locate. But it's fair to say if they're located within the confidence interval, the sample information is consistent with my H0, So we conclude H0. If it is outside, doesn't matter if it's on the left or on the right, outside the range, the confidence interval, it is inconsistent with our H0. As a result, we reject it and conclude H1. Any question here? I'm going to give you a second to write this down, and feel free to ask any question. It's really important that we have addressed the relationship from something you already know, already familiar with, confidence interval, to hypothesis testing. I can tell you when I was your age, this is such a confusing concept to me because I don't know what I'm doing with hypothesis testing. I'm doing all the calculation, I'm memorizing all this conclusion, but what is that for? Hypothesis testing is related to confidence interval. You certainly don't have to memorize how we draw the conclusion. If you can sketch the distribution, highlight the confidence interval, find out your sample located inside or outside the confidence interval, and then you draw your conclusion accordingly. You shouldn't have to memorize anything. Okay, let me check. Don't believe there's any question so far. Okay. Now let's continue. So, what is hypothesis testing? It helps us to draw a conclusion about the hypothesis testing. We always conclude from one of the two hypothesis statements. We either conclude H0 or we conclude H1. But the most important thing is you have to set it up correctly so you can draw the correct conclusion. Hypothesis testing procedure is verified by collecting random sample from your existing population. So you do need to go out there, perform experiments, and collect data to validate if the null hypothesis, the H0 is correct or not. And how to draw conclusion? We compare this sample information to see if it's consistent with the hypothesis. Hypothesis here is referring to the H0 specifically. If the information is consistent, that means my X bar is located between my lower bound and upper bound of the confidence interval. If that's so, we believe null hypothesis H0 is correct, and we conclude H0. If this information is inconsistent, that means my X bar is either less than my lower bound or my X bar is greater than my upper bound. It is outside the confidence interval. If that's the case, we believe H0 is false. H0 is false. So we reject H0, conclude H1. Over here, we fail to reject H0, conclude H0. Okay? So you will only have two conclusions, two possible conclusions. Fail to reject it, conclude H0. Or reject it, conclude alternative hypothesis. Okay, let's continue. Here is our 5 steps to perform a hypothesis testing. First, we need to identify, based on the problem, are we going to perform a hypothesis testing on population mean, standard deviation, or proportion? Okay, this is all capable of performing using a hypothesis testing, but for our lecture, we'll only focus on population mean. Then we formulate the null hypothesis and alternative hypothesis, my H0 and H1. After that, based on my H0, I have to generate a confidence interval. This alpha in our lecture, in your homework, in your quiz, is given. I have to give that to you so you can generate a confidence interval. But in reality, as an engineer, you have to decide, is 95% confidence interval accurate enough for the information I'm trying to learn? Or I have to raise it up to 99? Or this is just a survey data. We believe a 90% confidence interval is good enough. You have to make that decision. Pick your alpha, calculate that confidence interval. All right? Now let's start this one more time. I want to use this part, okay? This is my H0. That mu equals to 50. While my alternative hypothesis assumes it is not 50. All right? Based on our choice of alpha, we'll generate a 1 minus alpha confidence interval. Okay? So here is my alpha. Oops. This is my sample average. Okay, we believe in this population. My population mean is exactly 50. And here is my 1 minus alpha percent confidence interval. Right? Let's say the lower bound is 48. This is just a random number I picked up. And the upper bound, let's say, is 52. Okay, so these are the lower bound and the upper bound we generated based on our choice of alpha. Okay, so this 48 and 52 are our critical value. These are my critical value. It tells us where's the boundary of confidence interval, so we can make a decision if we're going to reject or fail to reject a null hypothesis. Next, we are going to collect our sample. We're going to collect data and calculate my sample average X bar. My sample X bar is my test statistic. Okay, this is the actual information coming from actual data. Okay, well, the critical value is determined based on my choice of alpha. Okay, in your homework, you'll see on web work, they divide it into several steps to perform hypothesis testing. At a certain step, you'll be asked to determine the critical value. At a certain step, you'll be asked to perform test statistics. A lot of students are confused with those two values. Okay, when asked your critical value, if you answer the test statistics, the answer won't be correct, and vice versa. So be very clear about those two different values. Okay. Okay. Then based on the location of my X bar is either located between these two values. It's either located here or located here outside. We'll draw our conclusion based on the location of test statistic relatively to the critical value. Okay, so what is my rejection criteria? if my X bar is located outside this confidence interval, we refer those two, beyond those 2 points are my rejection area, because we are going to reject my null hypothesis. Conclude H1 if my sample average is outside the confidence interval. Reject null hypothesis. Conclude H1. Okay, so these are my rejection area or rejection criteria. So let me write down rejection criteria actually. Rejection criteria is that reject null hypothesis when my X bar is greater than 52 or X bar is less than 48. In these two conditions, we're going to reject H0 and conclude H1. And where is the fail to reject area? This is my fail to reject area because my sample statistic is located within the confidence interval. Then we fail to reject the null hypothesis. And that's what we're going to conclude. Okay. So let's move on to step 5. Draw appropriate conclusion by 2 different ways. First, compare the location of test statistics to the relative location of critical value. Or there's something called p-value we can also use to draw conclusion. What is a p-value? Let me see. I'm going to use a different color. Okay. What is our alpha? Alpha is the sum of these 2 areas. These are my alpha over 2. Alpha over 2. These 2 sections add up to alpha. Okay, let's look at the green. What happens if my X bar is located outside the confidence area? That means my X also has a probability under this bell curve line. So this green area is my p-value. This is my p-value, or p over 2. This is my p over 2. Compare the p-value to alpha. Which one has a greater probability? Okay, I'm going to write it here. If, in this case, in my current case, my p-value is less than alpha, right? P-value is less than alpha. That means my sample test statistic is located outside the confidence interval. If that's the case, we reject the null hypothesis. Conclude. My alternative hypothesis. Vice versa, if p-value is greater than alpha. If it's greater than alpha, then my sample test statistic has to locate within the confidence interval. Since it's inside the confidence interval, we fail to reject H naught. Okay, so we conclude H naught. All right, so you can use either way to draw your conclusion from the hypothesis testing. Within chapter 9, we only have one population to perform hypothesis test. In that case, comparing test statistic to critical value is probably easier for you. But when we move on to two-sample hypothesis test or multiple population hypothesis test, p-value will be easier. Okay, but be familiar with both. In your homework, you'll be asked to do both. Any questions so far? Okay. So here is an example. If my null hypothesis believes my existing process has a mean population mean of 50 centimeters per second, while the alternative hypothesis believes it's not 50 anymore. Could be greater, could be less. So here is my sketch. It did the sketch without the distribution, but it's very similar to what we did over here. Oops. Very similar to this one that we just did. Okay? So they assume that's my sampling distribution. There is a sampling distribution right here. That's my confidence interval. Okay, so these two are my critical value. If my sample average is located within the confidence interval, we fail to reject the null hypothesis and conclude the null hypothesis. If it is outside, doesn't matter if it's on the right side or the left side, greater than 51.5 or less than 48.5, we reject it and conclude the alternative hypothesis. Reject it and conclude the alternative hypothesis. All right. I do want to point out that, remember, with confidence interval, we can do one-sided or two-sided. Okay. So let's give you an example of doing one-sided. One-sided hypothesis testing. Okay, so for example, I'm going to use exactly the same case. Mu equals to 50. Alternative assumes mu is greater than 50. Okay, and alpha is, let's say, 0.05. We're doing a 95% confidence interval. Okay, always start with a sketch of sampling distribution. We believe this population mean is 50. Alternative believes it is greater than 50, so we need a upper bound here. Okay, I don't know what that value would be, but this probability over here will be 0.05. I just made it up. I'm assuming this one is this is more 50.5. I don't know. Okay, so that's my one-sided confidence interval. Okay, this is my alpha. Okay, so if my sample average is located here, okay, x1 is less than 50.5, then we believe the sample is consistent with my null hypothesis. As a result, we fail to reject. H0 and conclude. My population mean is 50. Okay? The other case, if this is my population mean, x2 is already outside the confidence interval. Okay? That means that yellow sample average is coming from another population. Whatever that population mean is, it's not 50 anymore. Possibly a lot greater than 50. Okay, so if that's the case, my sample information is inconsistent with my null hypothesis. So as conclusion, we have to reject the null hypothesis. Conclude H1 that my new population mean is greater than 50. Okay? The procedure being exactly the same, but pay attention to how you set up your alternative hypothesis. Okay? When it's greater than or less than, that means it's a one-sided. Realistically, we don't use a whole lot of two-sided hypothesis testing in the real world. It makes more sense to get a more information from the testing to know exactly if it's greater on the right side or on the left side. Okay, two-sided only tells you it's either left side or right side, but nothing definitive. It just tells you your population mean has changed. Okay. So when you guys did your progress report, I made a lot of recommendation to do a hypothesis testing at different point. Some of my recommendation is applicable for a one sample hypothesis testing. Find out a reference value, for example, a salary reported of entry-level engineers, and you can use your survey data to compare if their starting salary is exactly the same as the reported value, or higher or lower. So when we move on to chapter 10, our null hypothesis will be performed between two populations. Okay, so a lot of you have comparing the data between male and female. That's a two sample hypothesis testing. Male is considered as its own population. Female is considered as its own population. And we want to compare to see if they are exactly the same or not. We'll talk more about that in chapter 10. Any questions so far? Okay. So we start introducing hypothesis testing by correlating that with confidence interval. As a matter of fact, I believe that's the only way to introduce hypothesis testing. If you don't relate something to the previous lecture, something you already know, it's so confusing to the students. Why are we doing this? What does that mean? Fail to reject. What is test statistics? What am I doing over here? That's all the questions I had when I was your age learning about hypothesis testing. So hopefully relate that to confidence interval, something you already know, or and also sketch it. Sketch it always helps you to highlight where is the rejection area. That's going to help you to draw a conclusion. Okay. One-sided, two-sided, we addressed that already. Now, this they've listed the type 1, type 2 error over here. Type 1, type 2 error over here, but we are going to come back to it. This is the most complicated idea of the entire 11 chapters we'll cover in this semester. So let's learn how to perform a hypothesis testing properly, and then we'll come back and tell you what happens when the sample you've collected lead to the incorrect conclusion. Okay, so we'll go back to here. This is going to be 2 weeks later. Right? So type 1, type 2, power, it's all week 3. We've talked about p-value. So we will show you how to use p-value to draw conclusion, and also comparing test statistic to critical values. Okay, that's all I have to cover today. All right, let's take a 10-minute break. We're going to start the test early. So come back at 11:10 and we'll start the testing. And while we're on break, feel free to unmute yourself and ask me if there's any question. Okay?